A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with some verses of Holy Quran. So today we are discussing about the topic of applied physics in the field of mechanics. Mechanics is related with mechanical engineering. So the branch of science which deals with the forces and their effects on the bodies on which they act is called mechanics. So the relevance of the forces and their impacts on the body which are act through the relevance of force, so that nature in science are we called the mechanics as well as in applied physics as well. Applied mechanics is also known as engineering mechanics in the branch of engineering which deals with the laws of mechanics as applied to the solution of engineering problems. So there are type of problems that are mostly relevant with mechanical engineering, materials, engineering mechanics related fields. So the study of that known and unknown problems in mechanical engineering are resolved by the applied mechanics of techniques as well. So after that, the application of applied mechanics are some of the important applications are also discussed as the principle and laws of mechanics are given below. The motion of vehicles such as train, buses, etc. are the examples of applied mechanics, as well as the design of building and forces on columns and on walls are also the reflection of applied mechanics. So now in this slide we are discussing the branches of mechanics which are relativistic mechanics, quantum mechanics and Newtonian mechanics. Relativistic mechanics are it deals with the objects moving with the velocities with the some kind of uh, rate of change of speed or rate of change of displacement are the called velocities comparable to the velocity of light. So it is the relativistic mechanics branch of applied mechanics. The second category is Newtonian mechanics. It is the branch of mechanics which deals with the effect of energy and forces on everyday objects. Now the third one is quantum mechanics. It deals with the behavior of matter and energy at atomic and subatomic scale. So these are the three branches of mechanics and their relevance of field. Now coming to the topic, a slide mentioned branches of applied mechanics. So in engineering mechanics, it divide mainly in two branches, which are the mechanics of solids in and mechanics of fluids. So solids are the solid material and fluids are the liquid based material. In mechanics of fluids are divided also in these the types: ideal fluids, viscous fluid, incompressible fluids. So these are the three further dividation of mechanics of fluids. Further, the mechanics of solids are divided into two main branches, which are the mechanics of rigid bodies and mechanics of deformable bodies. Mechanics of rigid bodies further divided into two main branches, static and dynamics. And dynamics also divided into two branches, which are the kinematics and kinetics. Afterwards, the mechanics of deformable bodies, which can deform their position, their shape, etc., are also divided into two categories, which are the theory of elasticity and the theory of plasticity. So these are the subsequent main and further branches of engineering mechanics. Further, the subject of applied mechanics is broadly divided into, so it's not specifically a subject, it's specifically a topic which we are discussing in thorough review based discussion and details. Broadly divided into the following two branches, which are the static mechanic is the branch of applied mechanics which deals with the forces and their effects while acting upon bodies which are at rest is called statics. Further, the second category of mechanics is the dynamic, the branch of applied mechanics which deals with the forces and their effects while acting upon bodies which are in motion is called dynamics. It is further divided into two types, which are kinetics, the branch of dynamics which deals with the relationship between motion of bodies and forces causing motion is called the kinetics. And the second category of dynamics is the kinematics. After kinematics is the branch of dynamics which deals with the motion of bodies without considering the forces which cause motion is called kinematics. Now further we are discussing about the physical quantities. Any quantity which can be measured is called a physical quantity. So it can be touchable, it can be measurable quantity, we call a physical quantity that having some kind of magnitude, that having some kind of physics of their physical aspect. There are two types of physical quantities, fundamental or basic quantities. The mutually independent quantities are called fundamental or basic quantities. Drive quantities are the second category of physical quantities which are the derived from basic units. So the quantities which can be expressed in terms of fundamental or basic quantities are called drive quantities, etc. And these drive quantities which are derived by the basic quantities are we all know that the velocity is the ratio of displacement, which is a vector quantity, divided by the time scalar quantity. So length over time become meter per second of unit of velocity. Linear momentum, the mass over multiplied by the velocity, is also a drive quantity by these two things. There's the combination of mass is the basic quantity and the velocity is a drive quantity become a drive quantity. So the combination of basic fundamental quantities and the combination of some drive quantities are also make a drive quantity. It's a phenomena in drive quantities. So linear momentum and velocities, power, other kind of examples are the drive quantities. And I again repeat this statement that drive quantities are drive or made by the basic quantities. Rigid body. A rigid body may be defined as a body which does not changes in shape and size under effect of forces acting on it. So the rigid body is a particular body that it cannot be changed its size and shape in another kind of physique of aspect due to the acting of force on it, act on it. In fact, nobody is perfectly rigid. Everybody can act upon by external forces. The other kind of external forces are the environmental aspect forces and the all the other aspects related to the relevance by which the rigidness can be observed, that external factors I'm talking about that will undergo certain changes in that particular body. So we are further coming towards the topic that is the scalar and vector quantities, which are already covered in our previous sessions. So it's a review that scalar quantities are those quantities which, to mention them by their uh, direction and as well as the mass, they are called uh, the vector quantities. The examples of vector quantities are velocity, acceleration, momentum, and impulse, forces, etc. And the second category of is called the scalar quantities, to nominate and to mention the physical quantities by their its only magnitude. Direction is not mandatory for them. So those physical quantities are called scalar quantities. Example of these scalar quantities are mass, length, density, work, pressure, heat, and current. Because to nominate and to mention these quantities, we don't need any kind of direction. We only need its magnitude to mention it. So these are the scalar quantities. Now coming back to the topic which we call force. This force may be defined as a push or pull, either changes or tend to change. Either changes and tend to change means किसी चीज को मूव करना या मूव करने की कोशिश करना, that is called to tend to change and change the state of the rest or of uniform motion of a body. Force is a vector quantity which is measured in Newton. So characteristics of force are the following characteristics of force, which are the magnitude. The quantity of force is called its magnitude, such as 50 Newton, 80 Newton, and 25 kg. These are the magnitude oriented force act by the body. So other characteristics of force, the second one is direction. The direction of force is the direction of the line along which it acts. So we can also set this, we can also say this thing that the force is in the same direction by which it applied. It cannot be possible that we applied the force in another direction and the body is moving opposite its direction. So the force direction always in the direction of body. Nature of the force or sense. This is the third characteristic of force. Nature of the force means whether the force is a push or pull at the time of application. So in this slide, we are going to discuss the concept of effects of a force, specifically on a body. A force acting on a body may have the following effects on the body, which are: it may be change the state of rest or of uniform motion of a body. It may change the direction of motion of a moving body as well, which is the second category. And then the third one is it may change the shape, internal stress in the body as well. And coming back to the fourth category of effect, it may produce internal stresses in the body as well. So these are the effects which are made by the force. Representation of force. So in the slide, there are two types of different methods of representing a force. First one is the vector representation. In this method, a force is graphically represented by a straight line drawn parallel to the line of action of force on any suitable scale. So you can see that the two forces, one is the moving towards the negative x-axis direction, and another force of vector start from the end of f of x factor, and vertically drawn, that is factor we call f of y, the vertical y-axis force factor, and the summation of both these two things we call resultant vector. So Bose notation is another category of method to designation of a force by writing two capital letters on either side of line action of force. The marking of capital letter can be done either in clockwise or in anti-clockwise. So this is another representation of a force. Number one is the vector representation, and number two category of force representation is Bose notation representation. So another aspect related to the force is force system. So force system, as per the graphical representation, we can observe that the force system is divided into main two parts, which are coplanar and non-coplanar. Coplanar means all the forces act on a same plane, which are called the coplanar acting of forces into a single plane. And non-coplanar means different kind of forces are act on a different unweighed surfaces and unplanned surface, which are not linear. That particular forces are non-coplanar forces system. Further, the non-coplanar system divided into three categories are the parallel, concurrent, and non-concurrency. So these are the category of non-coplanar force system. The second category of force system is coplanar, which all the type of linear forces on act on a linear same plane, which we call the coplanar, and categorize into four parts of collinear, parallel, concurrent, non-concurrent. So these are the force system, which is the collection of several forces acting simultaneously. That many forces act simultaneously means act on a single uh, time of a span. On a body is one or more plane that is mentioned in figure F1, F2, F3, and F4 continuous force acting on a same system in the different aspects. Okay, further we are discussing the concept related to the equilibrium of a particle in space free body diagram. In free body diagram, we are explain the things in this way. To study the equilibrium of body, equilibrium is the balance position of any body or the position on which all the acting of forces act on a single body and cancel each of one its effect. Its state we call an equilibrium state of a particular body. It is a magnitude that the supports are replaced by the reaction exerted on body. A diagram of an insulated body which show only the reactions acting on the body is called a free body diagram, which is we called in short FBD. In free body diagram, we can say that the weight acting on downward direction and its normal reaction force act in upward direction. So these are two forces which are balanced with each other. We applied a force from this direction, from left to right direction, which is F, and the friction force, which is opposing effect applied by the body and in between the surface, which is the friction force from right to left. So these are also forces which are overcome to each other. So the concept of equilibrium is very well understood by this free body diagram, that all the forces acting in this single body are balanced with either equilibrium in position and cancel out their each of one effect by 1 each. So we can say that this body is in equilibrium, balanced position, stable position, and the concept we understood by free body diagram. So this is all about today's session of applied physics. If you have any kind of question, query, or difficulty regarding today's session, please feel free to discuss. I will answer the kind of question and resolve your queries if you have in your mind. If all the things been clear in your mind, then we are ending today's session. Thank you very much.